Alright, so we're going to look at the review for your trigonometry test today. It's not the exact same numbers as the one that you have. You have the answers at the back, but this is the same process. So starting off on number 1, tells us angle A is 40.8, BC is 38, and we want to find AC to the nearest tenth. So AC is here. Alright, so from here we've got AC has to be the hypotenuse. 38 is the opposite. We go to our SOHCAHTOA. Again, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Again, when we're setting up the function, it works that way. Since we have O and H, this is going to be sine. Sine of your angle, 40.8, equals to the opposite, 38, over x. Now our variables on the bottom, when our variables on the bottom, we switch these values. So this is x equals to 38 over sine 40.8. Alright, now that we've got to this point, we go to our calculator. We're going to again make sure our calculator is in degrees. So to do that, we go to mode. We go down to the third option, we highlight degrees, we hit enter, and to go back, we hit second mode again, sends us back this way. Alright, so now that we have it in degrees, we're going to do 38 divided by sine 40.8 gives us our answer for this problem being 58.2. Alright, then that takes us to number 2. So number 2, we got C is 35.1, BC is 27. We are looking for AB. Alright, so x is across from it, so that is opposite. 27 is next to it, but not the hypotenuse, so that is adjacent. O and A tells us tangent. So tan 35.1 equals to, on this one, x over A. And this is not A, this is actually 27. So x over 27. Our variable now is at the top. So when our variable is at the top, we take the bottom and multiply. So this ends up being 27 tan 35.1 equals to x. Go to our calculator, 27 tan 35.1. And we hit enter. And our answer is now 18.97. Alright, that 7 around this 9 up, so this actually becomes 19 for our final answer. Alright, on the paper that I have, I don't have any of them that are finding the angle for just one of these straight up problems, so I'm going to draw one. Let's just say we're going to go for this, and let's call this TRI for triangle. And we're going to look for angle I. Alright, so let's say that this side is 17, and this side is 25. We can find x by doing the same thing. So this is adjacent, this is hypotenuse. Adjacent and hypotenuse tells us cosine. So cosine your angle x equals to 17 over 25. The variable's now on the left. So if the variable's on the left, you do the inverse. So this is inverse cosine 17 over 25. Go to our calculator. To do the inverse, we hit second first. And we're going to put 17 over 25. And it gives us our value that x is 47.2 degrees. Alright, so starting on this one, number 3, we now have a 45, 45, 90 triangle. It tells us R is 45 degrees, and then TR is 50. We want to find FT, so FT is down here. Okay, so with this, there's two special right triangles that you have. The 45, 45, 90, which is now being drawn on the screen. Alright, on a 45, 45, 90, since the 45 angles are the same, the legs have to be the same. Now, to get the hypotenuse, that is whatever the leg is times the square root of 2. So in this situation, what I have is I'm given the hypotenuse and I need to find the leg. So the hypotenuse would be x square root 2. This would be x. So to go this direction, I have to get rid of the square root of 2. This is x times the square root of 2. So the opposite of x times the square root of 2 is x divided by the square root of 2. So we're going to get rid of the square root of 2. So we're going to take 50 and divide by the square root of 2. Now here's where we go to the problem. We cannot have a square root in the denominator, which means we can't have it on the bottom. The way that we get rid of it is whatever is in the denominator, we're going to multiply top and bottom by that value. So when we do this, on top, 50 and the square root of 2 don't mix, so we have 50 square root of 2. Square root of 2 times itself, anytime you have a square root times itself, you get that number. Now here's the good part about this. We have to look to see if the whole numbers can reduce. If 50 can divide by 2, then we'd have to reduce it. Right? 50 is even number. Any even number can be divisible by 2, so we're going to reduce this, and we get our final answer, 25 square root 2. Now, 45, 45, 90s are not the only special right triangles that you have. You can also have 30, 60, 90s. That's what this next one ends up showing. It tells us T is 60 degrees. TH is 100. We're wanting to find HR. Alright, so on a 30, 60, 90. Okay, on a 30, 60, 90, you have 3 different sides. Alright, because we have 3 different angles. Okay, we base everything off the short angle, which gives us a short side. So across from 30, we're going to call that x. Now, the long leg, which is the other leg, the one that's touching the right angle, is whatever the short leg is times the square root of 3. And the hypotenuse is whatever the short leg is times 2. So since we have this one, what we have is our short leg. We need to go to our long leg, so we need to go from x to x squared of 3. So what we're adding to this is actually we're multiplying by the square root of 3. So we do this, 100 times the square root of 3. Alright, those don't mix again. We have a whole number and a radical, we can't mix those up. So this gives us our final answer is actually 100 square root 3. And that's in radical form. When we mean radical form, it means we have the radicals on here. Okay. Technically, you can do trig on this, but you're not going to get it in radical form, so you would lose points. Alright, so this next one deals with the same problem. We got R is 30 degrees, HR is 100 now. We want to find TH, so TH is now here. So if we follow the same rule, this would be our short leg x, this would be our long leg x square root 3, and then our hypotenuse is over here, but it doesn't really matter about that one. So we need to go from x square root 3 to x, so the way you undo multiplication is divide. So we're going to take 100 and we're going to divide by the square root of 3. Just like on number 3, we can't have the square root in the denominator. So the way that we get rid of it is multiply top and bottom by that square root. When we do that, again, 100 times square root of 3 can't mix. We get 100 square root 3. Okay, on the bottom, square root times itself gives us that number. 100 is not evenly divisible by 3, so this is our simplest radical form. This then takes us to number 6, where we have T is 60, TR is 100, okay, and we want to find TH in simplest radical form. So TH we're looking for here, Alright, so in order to do this, we have now 2x. We want to go to x. So to go from 2x to x, we gotta get rid of that 2. So the way we do that is divide by 2. This would be 100 over 2. Alright, so that just gives us 50 for our answer. Now, if we were to take this and then try to find the other side, what we'd have to do is then go to x square root 3. So what we'd have here would be 50 times the square root of 3, which is a perfectly good number, 50 square root 3. Alright, so now we are getting back into word problems with the camera mounted at a point 4,100 feet from the base of a rocket on a launching pad. Alright, so I'm going to take a little bit of time and actually draw this picture. Alright, so here's a rough sketch of the rocket with the camera. Alright, assuming it's 4,100 feet from the base, here's 4,100 feet. And the angle of the camera is 20 degrees. How high is the rocket? So this would end up being our x here. Alright, so again we have an angle that's not 30, 60, 90, so we have to do trig. So we're going to end up going with this, where we have now x is opposite, 4,100 is adjacent. So we are going to do tangent. So tan, our angle 20 equals to x over 4,100. Variables on top, so we multiply. 4,100 tan 20 equals to x. Go to our calculator. 4100 tan 20. And our answer, we want this to the nearest foot, so we are going to go with 1492 feet. And there's our final answer. Alright, number 8, we have a ladder leaning against the side of a house. The ladder is 13 feet. It makes a 58-degree angle with the ground. How far up the side of the house does the ladder reach? Alright, so let me draw this picture. Alright, so here's our house. Alright, we have the ladder that's 13 feet tall. The angle at the ground is 58 degrees, and the height of the ladder is height up the side of the building is what we're looking for. So the height is across from it, so that's the opposite. The 13 is our hypotenuse. So if we go back to SOHCAHTOA, that is sine. So sine your angle 58 equals to x over 13. Now our variable is now at the top, so we take the bottom and multiply. This gives us 13 sine 58 equals to x. So now we just go back to our calculator. We type in 13 sine 58, and our answer is 11.0. So we'll just call this 11. Oh, it says round to the nearest 100. So 11.02 feet. Alright, and there's our final answer. Alright, so number 9 is not one that we have actually looked at exactly in this way because it's worded a little differently. Great, it talks about slope. So remember, if you talk about slope, slope is rise over run. Alright, so if we're talking about a skateboard ramp with a slope of 3/2, that means that it goes up 3 units for every 2 units it goes left or right. So this would be our ramp with the slope of 3/2. Okay. We want to know what degree angle it has with the ground to the nearest degree, so we're going to go to a whole number. We want to know this would be on the ground here. Okay. So 3 is opposite, 2 is adjacent, trig function that uses opposite and adjacent is tangent. So tan your angle x equals to 3 over 2, opposite over adjacent. So when we are going to do this, variables on the left, we do the inverse. Inverse tangent 3/2 equals 2x. So we go to our calculator, second tan, 3 over 2. 56.3, which rounds to just 56 degrees. So again, just because it doesn't necessarily give you both sides, you can find the ratio of the sides based off of that slope the same way that you would if you actually had the side lengths. Alright, so on number 10, whenever I added this one to this page, it left it multiple choice, but we can still do this. Now, I will tell you this question is not one of the ones that's on your test, but it's still stuff that we've actually have talked about. So what it says is AD is perpendicular to the radius of each circle. So that means that we have 90-degree angles here and a 90-degree angle here. It says if BA equals to 7 inches, right, so we have 7 there, and AD is 27 inches. Wants to know, and it also tells us BC is 43 inches. So 43 inches here. It wants to know what's the radius of circle C. So the radius of circle C would be this entire length here. Now, in order to do this, we need to use Pythagorean theorem. So we're going to draw basically this bottom whole section as a rectangle. Alright, so if this whole bottom section is a rectangle, the bottom, or this side of the rectangle here would also be 7. Alright, now above it, now this 27 moves up here, and notice we have a right triangle where we have 2 sides. So we can find the third side with Pythagorean theorem. So a squared plus b squared equals c squared. C is the hypotenuse, which is by itself. So we're going to put 43 by itself. Okay, and then we're going to do that equal to x squared plus 27 squared. So go in our calculator. 27 squared gives us 729. And 43 squared gives us 1849. So x squared plus 729 equals to 1849. We subtract 729. And that gives us 1120 equals to x squared. But we don't want x squared, we want x, so we square root this. So second square root 1120, and that gives us x equals to 33 point, it says nearest tenth of an inch. It only ends up having the actual inches for the answers on here, but we're getting here, so we'll round this to 33.5. Alright, so now this is only the top portion of this, so 33.5. So when we go to here, we need to add the 7 to it. So plus 7 gives us 40.5. So if we were looking at any of these answers on here, it would be A. But your actual correct answer would be 40.5 inches. Alright, your test will be tomorrow. Now, the good thing about this review is that now you actually have another review that's basically the same as this that you can do on your own. You have the answers at the back of the review, so you can use those to study and make sure that you do everything correctly. Again, your test will be tomorrow. Good luck.